My dear friends, today I am going to explain how we can find the value of capacitance of unknown capacitor. This is our unknown capacitor and we are interested for finding its value, the value of the capacitance. Okay, these are the 2 points which can be used for the connection for this capacitor. Okay. Now this circuit for that is called the DeSauty bridge. And what it is actually? Very simple. You know, we are having 2 resistors. One resistor is fixed. This is one resistor is fixed. This is 1 kilo ohm. And second resistor is R2. This is variable. If the knob is here, the value is 2 multiplied by 1 kilo ohm, means 2 kilo ohm. If the knob is here, the value will be 4 into 1 kilo ohm, means 4 kilo ohm. So R1 is fixed, R2 is variable. Our unknown capacitor will be connected between this point and this point. Okay. And we will give AC to bridge circuit between. Now there is another capacitor which is fixed inside this box, and this is a knob or the dial. We can have any value of capacitance, variable capacitance from this capacitor. Okay, this is known capacitance. Unknown capacitor will be attached between the 2 points. So this is known, this is unknown, this is fixed resistor, this is variable resistor, and from audio oscillator, here will be the input. Now there is one more connection in this detector. This will go through detector. What is the detector? Detector will tell us that, in bridge circuit, there is a resistor, another resistor, one capacitor, another capacitor. So between this point and this point, there is an audio oscillator. Audio oscillator is connected between this point and this point. And between this point and this point, there is a detector which will detect whether some current is flowing through this path or not. If the detector tells us some reading, that means current is flowing. If it gives a 0 reading, that means no current flowing along this path. Then the DeSauty bridge will be balanced. Okay, and our work is how to balance, how to have 0 reading from the detector by varying, this resistor is variable and this capacitor is variable. Like this is a capacitor which is variable. You go on varying the capacitance, go on varying the resistor till the detector gives a 0 reading. Okay. Making the connection How? The unknown capacitor, it is attached here between the 2 points. Okay, unknown capacitor is attached here. And this is audio oscillator. This is audio oscillator. External source means AC. AC is applied here between the 2 points. External source means you are having AC. Low AC and high AC. There are 2 buttons. The switch may be at low AC or maybe at high AC. This detector and detector is attached here. The detector is attached here. And switch on the circuit. It is giving some reading. That means bridge is not balanced. It is at the switch is at low frequency. This is at 2 kilo ohm. This is at 2 kilo ohm. Now we gone varying the capacitance like this. We gone varying and we'll find simultaneously the reading from the detector. Now reading is decreasing. Okay, good. Still decreasing. Okay, fine. But this is 0.2 and even 1.10. This is a minimum, I think. But again it is increasing. But we'll find the minimum, that is 0.10 or 0.09. Now this is almost 0 from detector. Now bridge is balanced. You note down what is this 2 kilo ohm. You note down the capacitance from here. What is this value? Okay. This is not 600. This is between 500 and 600. Close to 600. Okay. Again it is increasing, The bridge was balanced near 600. It is giving minimum reading here. Again it is increasing. So we have to set this dial where the detector gives a minimum. Again it is increasing. Okay. Now it is decreasing. Now here again, it is minimum. So you have to set the value unknown capacitance till the detector gives a minimum reading. Similarly, you repeat at for the high frequency. Now this is at high frequency. Again we are repeating. Now again, it is decreasing. This is high value. Now decreasing. Okay, go on changing the capacitance of non-capacitor till now 0.19. But 0.19 I think it was minimum. Now this is not minimum. Again it is 0.16. This is minimum at high frequency. It was 0.16 minimum. You note down what is the value of the non-capacitance. So this is, I think, between 400 and 5, between 400 and 500. Between the 400 and 500. Exactly you note down what the value is. Okay. So this is all. DeSauty bridge. So basically, it is a bridge circuit. Here there are four arms. We are having a resistor of resistance R1 here, and second resistor of resistance R4. In this arm, we are having a capacitor of capacitance C2. In this arm, again there is a capacitor of capacitance C3. Okay. Let AC source is connected here. With this AC source, current starts, let it is I. When I will reach here, it finds the two paths. Some current will go through R1, it is I1. Some current will flow through R4. Let this current is I4 because the name of resistor is R4. That's why name of the current is I4. Now when this current I1 is flowing along this path, when it reaches here, it finds two directions. It can go along this side and it can go along this side. Let along this side the current flowing is I2, and again the current I4 is flowing through R4, reaching let which passes through C3. Let it is I3 because the name of the capacitor is C3, so name of the current is I3. And whatever the splitting of the current, but when the current reaches here, it becomes of the same value, which is I. Okay, now according to Ohm's law, you know what is the Ohm's law? Ohm's law is the voltage is current multiplied by the resistor. Okay, let voltage between the points A and B. So what is the voltage between point A and B? It is I1 R1. Okay. Now what is the voltage between point A and D? It is I4 R4. What is the voltage across the capacitor C2? This is current multiplied by the capacitive reactance, which is minus J is the J operator. It tells us about the phase. Okay, J operator. Then what is the capacitance C2? Then omega. This is the capacitive reactance of C2. Now then, what is the voltage across C3? It is I3. It is I3 multiplied by the capacitive reactance. Again minus J upon C3 omega. When the bridge is balanced means no current will flow along this path, along this line. No current is flowing along this line. When the bridge is balanced, no current is flowing along this line, means this point and this point, they are the same potential. Whatever the potential here, the same will be here. That means potential across R1 and potential across R4, they are equal. Similarly, the potential across C2 and potential across C3, they are also equal. Right? One thing again, because no current is flowing along this path, so it implies I1 is equals to I2. Okay, because whatever the I1 is coming, it then goes through C2. No current will flow through this line, through BD. So substituting I1 equals to I2 here. Substituting I1 equals to I2 here. This expression becomes I2 R1 is equals to, now when R1 equals to I2, I4 will be equals to I3. So instead of writing here I4, I'm writing I3 multiplied by R4. R4 means this is not R3, R4. You find I2 from this expression. I2 becomes, I3, R4 upon, R1. Okay. Now substituting this I2 here. So it becomes I3, R4 upon R1. Then this expression, okay, is equals to I3 and minus G, then C3 omega. It is here. So certain factor will cancel out, like I3, omega and omega likewise. And what we left? We left R4 upon R1. R4 upon R1 equals to C2 upon C3. So this is a standard relation, and you can use it for finding if you know the two resistors, and if you know one capacitance of a capacitor, then you can find the unknown value of the capacitor. If it is unknown, suppose C2 is unknown, this is unknown capacitor, then because you are having R1, R4, C3, then you can find it easily. But one thing is there, if the capacitors are not free from dielectric losses, they are not free from dielectric losses, then finding the balancing point becomes difficult. You will not find null point here. Null point means zero deflection of the galvanometer. It will be difficult if the capacitors are not free from the dielectric losses. Otherwise, there is no problem. Very simple. Bridge balance means they are at the same potential, no current will flow. Then, this potential will be equals to this one will be equals to this, and from here you find the required relation. Okay, thank you.